Good afternoon. We are Team Autonomous Transportation for Autonomous Vehicles. We're a Senior Design 2 team. Our project is based around the idea and field of automotive telematics, which is kind of a combination of wireless technology and sensor devices attached to vehicles for transportation purposes, for safety purposes. And our project was basically how could we take autonomous vehicles, a world full of autonomous vehicles, what could we do with them? And one idea we had is with them you could eliminate traffic. And the way that we implemented this is we have the vehicles talking to particular base stations that are implemented within the roadway system, and they control the speed and the direction of the vehicle. We believe that if you can control the speed and direction of each vehicle, then you can control the spacing between the vehicles and you would eliminate traffic in high traffic areas. We created a small scale of a real world problem, and to do that we created our own autonomous vehicle that is controlled by, we have sonar sensors around it that sense the world around it. We've tried other implementations. We tried a line following where we had an array sensor on the front that's still on the front there, and it detects light intensity. So as we change the light intensity, the car knew where to go. We ended up going with the sonar system to control our, what we call the local positioning system, as opposed to a global system for our small world scale. And the way it works is it works kind of like a barcode system. As the car drives down our model road, it passes little markers. And the markers are hit by the sonar, and it reads it as a barcode. So one side, if it reads it, it'll be a 1, one side will be a 0. So as it's going down the road, it's sending the information back to the base station, and the base station says, okay, I know exactly where you are, this is what you need to do. You need to turn right, you need to turn left, going straight. So that's how we handled the problem of implementing a real-world system in a very small scale. We have collision detection on our vehicle as well. If objects, come to encounter the vehicle too closely, the vehicle automatically stops. If there's loss between the vehicle and the base station, the vehicle can go into auto drive mode, which we feel like a real-world system would need. But if there was loss between the vehicle and the bases inside the road, the cars still need to be able to function. And most vehicles now, the Google car, things like that, they're self-driving, so we just go back into that system. Anyway, one of the applications you can use this for is traffic rerouting in case there's accidents. So if you have the autonomous vehicle, as opposed to somehow telling all the autonomous vehicles there's an accident, the base stations would be able to alert the vehicles that there is an accident here, and it can reroute traffic around accidents, around road closures, around I don't know, water line breaks, and any other things that happen. And as far as what we contributed, I contributed most of the programming. Joshua Cora had most of the sensors, and Shayla had most of the other everything else we did. Well, thank you very much, and we'll open to questions.
Right. Do you have any questions?
From the vehicle to the base station, was it two-way communication?
It is two-way communication, so that's how the vehicle knows that there is a base station there. It'll send a signal, here I am. The base station will send a signal back, okay, I see you, what's your coordinates? And then he'll send it back, or what's your direction, which way are you going? So it's two.
And what network did you use for that?
We used RF wireless between our car and our base station.
Okay, so you rolled your own.
Yeah, we just used our own. Yeah, we created our own implementation of it.
Did you test this with more than one vehicle?
Well, our Senior Design 1 project had 2 vehicles, and we kind of simulated an intersection. And we have it tested with that. We have another vehicle, but we were having problems with it. So we couldn't bring them both to demonstrate 2, but we have tested 2 on the road at a time. And as long as, for our simulation, as long as they weren't too close together, then the base station, we keep track of both of them.
Do you see any applications here to groups of drones flying together?
Oh, absolutely, yeah. It would be the same idea with one base station. So the vehicle or the drone would control its own little small area, and then the base would control all of the others, absolutely.
Any more questions?
Right, so, Mr. Tim, thank you.